So if the discriminant is a positive number, you're going to have these two solutions. If the discriminant is 0, then that graph turns on that x-axis. Okay? If it turns on the x-axis, then the graph is one of those types of ones that you can factorize, which is called a perfect square. If the graph doesn't touch the x-axis, it is because the discriminant is a negative number. Okay? With all of these parabolas, because they are a x squared, they should all have two solutions. So you need to be aware of the terminology that's used. Okay? This one here has two solutions, doesn't it? Those two solutions are just imaginary. Happy? Let's give me something to hear then. This one real root is two identical roots. It's the same thing. Two repeated roots, two identical roots, one real root, the perfect square. All of those things are what we would describe as having a discriminant as equal to 0. Okay? And this one here is two distinct roots where the discriminant is a positive number. So the questions I'm asking you now, which are more at the external type questions. For what values of p will it be a perfect square? What does that suggest to you about the discriminant? Yeah, it suggests that the discriminant, which is b squared minus 4ac, equals 0. Happy with that? So what we do now, a is p, b is negative 4, c is 16. So negative 4 b squared minus 4 lots of a, lots of c is equal to 0. Happy with what I've just done there? What are we going to do now? Yeah, pretty much do the calculations. Get rid of those brackets. Negative 4 squared is 16, minus 4 times 16 is 64. So 16 minus 64p equals 0. Okay? So 16 is 64p. Then you divide both sides by 64. So p is actually a quarter. Okay? Happy with that? Now I'll pause the video here.
16.
So here what I've done is I've graphed this one here, this p squared minus 4x plus 16. And I've put a slider in Desmos of p, so we can change p and see how the graph changes. So hopefully you can see here that when I change this p, what happens to the graph? It's changing, eh? Okay, so when we're saying at p is a half, how many solutions are there?
2.
Well, no, well, yeah, there's 2, but they are imaginary, yep. So if we change that a half to a quarter, I want to do it on my computer. What's happened? One real, 2 repeated. It's a complete. It's a perfect square.
So we're looking at the vertex.
Because the vertex turns on that x-axis, there's only one real solution, or 2 repeated solutions, whatever we want to call it. And if I change that and make it less than, what's happened? And how many solutions are there? Okay, everyone happy with that? So as long as p, the value of p, that makes this graph here have the one solution, it is 0.25 or a quarter. That's the value of P. So that's what you just found out. Happy with that? So the next one then. The next one. For what values of P will the roots be real? So what is that asking us to do? Discriminant equals 0. Are they real? Discriminant less than 0. Are they real? Discriminant greater than 0. Are they real? So what we're looking for then is where does b squared minus 4ac, where is that greater than or equal to 0? Both of these conditions here. Happy with that? Substitute in, so it's going to be negative p squared minus 4 lots of 2 lots of 1 greater than or equal to 0. What do we do now? So p squared minus 8 is less than or equal to 0. Okay? What does that mean? Plus 8 to both sides. What do you do? Square root both sides. So p now is greater than or equal to the plus and minus square root of 8. Is that right? Everyone happy with that? So if I was to draw a real quick sketch of this graph of your solutions, there's 0. Here's root 8. Here's minus root 8. Anything greater than or equal to root 8, where does that lie on my number line? Anything that way, Solid dot because it includes. Because greater than root 8, just then. What about everything that's greater than negative root 8? Where's that?
Wait.
Hold on. Greater than negative root 8. That's same place, say. So what is this greater than root 8 one? What is that there for? This here is wrong. Okay? It's just minus root 8. I'll have a look at it. This is where it gets a little bit more confusing. So what I'll put up now is the graph, the purple one, which is actually the graph that we're looking at. We're trying to make that graph there have two solutions. So what happens is when I make this number big, it gives us two solutions. Everyone happy with that? Two solutions. When I make this number smaller, it gets to a point where there's going to be one solution. Gets to a point there's no solutions. Then it gets to another point where there's going to be another one solution, and then it's going to get to another point where there's two solutions. Okay? Happy with that? And these points come from this graph just here. Okay? What is that graph just there? X squared minus 8. That is the graph of this one here, eh? If you think that x squared minus 8 is the same graph as p squared minus 8. Yeah? So where is this graph here, which remember is the same as x squared minus 8 graph, where is that graph greater than 0? Looking at, where is that graph greater than 0? When it's greater than that, eh? Or where it's not greater than that, but less than that. Can you see that? So my answer here, to answer this question, basically what I do is I go, rightio, let's solve p squared minus 8 equals 0, which I solve exactly how you guys solved it here, and get an answer of p squared is equal to, p is equal to plus and minus root 8. Okay? But then I think about what this graph looks like. And that graph there looks like that. with two answers there and there being these two answers of plus and minus root 8. And so where is the graph positive? Positive root 8 and less than negative root 8. So that is actually your solutions there. Okay. Now that there is your excellence thinking. That's your quite abstract type thinking. So we're going to have to practice that. What we're going to do today is we're going to practice more like the first ones, where we're just going to get linear inequations and linear equations that we can deal with. We'll have a look at quadratic inequations at some stage, maybe later today or maybe on Monday. Questions, problems?